presentation is on the topic of cross-platform network filtering. Tavleen is a production engineer at Meta, part of the infrastructure security engineering org. Her primary focus is on managing Capirca, a cross-platform ACL management service that plays a critical role in safeguarding Meta's edge, backbone, and corporate networks. We welcome her to the Nanog stage today. And looking forward to your presentation. Thanks.
Hi, good evening, everybody. My name is Tavleen. I am a production engineer at Meta and pretty much, yes, part of infrastructure security engineering. So today I will be talking about cross-platform network filtering and how we do that at Meta and how we solve this problem of managing managing ACLs at scale at Meta. So let's get started. I'll first briefly walk through the agenda. We'll be talking about different aspects of security and then types of filtering, a brief introduction to firewall ACLs, and then we will deep dive into Capirca and the config generation workflow. I will then talk about the safety services that we've built in Capirca, which include risk assessment and some flow guardrails, and then I will go through the conclusion. All right, so let's talk about different layers of security. Security is a very non-negotiable component which I'd say you have to deal with when starting to build a product, trying to manage a company's resources, and making sure that a company's infrastructure is protected at all times. Since security is layered, which means at every layer we need to make sure that we are protecting the infrastructure from attacks and threats. Physical security involves securing our data centers and POPs by the means of card readers and cameras. Next we have is network security, which I will be talking more about today, but trying to protect our network infrastructure from DOS and threats attack. Host security involves protecting mobile devices and PCs which are hosted inside of our company from various attacks. Then we have application security, which means trying to secure the different mobile and computer applications. And finally, data security, which is trying to secure data at rest and data in transit, which involves a lot of encryption techniques as well. There are multiple types of filtering. We will focus more on network-based filtering today. So network filtering involves taking necessary measures to protect the network infrastructure from unauthorized access, attacks, and misuse. We need to protect the sensitive data hosted inside of a company. We need improved network performance, and all of this, if the network's up and running at all times and our users can connect to our family of apps at all time, this basically means we're able to save a lot of cost in millions. Firewall is the most basic component when we talk about network security. It is a device that monitors incoming and outgoing traffic inside and outside of a company. Firewalls do something called as deep packet inspection in order to make sure that the packet that comes in matches, statefully matches, and depending upon that, we allow or deny traffic. Firewalls are stateful, which means only the first packet in a session needs to be deeply inspected. All the subsequent packets match an existing session and pass through the firewall. Next is an access control list. It is a defined set of security rules that is added to a firewall. The network filters match traffic based on information on the packet, which is source IP, source port, destination IP, and destination port. This is a very simplified diagram of where we place a firewall. again, the firewall can be placed inside of a company also. At Meta, we have different segmentation layers. So we do place firewalls in a lot of places, but in general, we always have a firewall placed on the boundary that connects a company to the internet. And we have access control lists applied on the edge. That's called the edge of the network. So what is the scale of the ACLs? At Meta, we manage close to 30,000 access rules, which contain roughly about 550,000 addresses. This generates close to 1 million access elements across all our DCs and POPs. So with that scale, it is close to impossible for us to maintain ACLs manually. Some issues that I will talk about, different ACL syntaxes. Currently at Meta, we have about 10 to 15 different vendors of firewall vendors, and it is very difficult for us as a security team to be able to learn the syntaxes of all these various vendors, and for also all the other users in the company to learn it. So, and of course, it is prone to manual errors, slows down the users that are trying to open up a new rule because they either have to wait for the security team to take action on their request, or they have to learn different syntaxes to be able to do that. And swapping or upgrading a hardware is a nightmare if we have to manually do it. So in order to help with all of this comes Capirca. Capirca is a cross-platform ACL management tool that we use at Meta to manage firewall ACLs from different vendors. It is an open-sourced network policy compiler by Google. At Meta, we've changed it to be a self-service tool where users can write their own configs without the knowledge of any vendor syntax, and in some cases also self-approve their changes. I will talk about about the self-approve part in a little bit. Let's take a deep dive inside of Capirca. The first and foremost thing in Capirca is the Capirca object. These are entities that exist as separate components, but they can be reused inside of config files. The first Capirca object or the entity is a network. A network is a set of IP addresses that you open or deny access to and from. A single network can contain a single prefix or a list of prefixes depending upon what you want to open or close access to. At Meta, we support something called as dynamic network definition. So some networks change at a regular cadence, and it is not possible for users. When I say users, I mean different teams inside of Meta that interact with firewalls. It is not feasible for them to keep updating their rules every day. So instead of specifying the prefixes, they specify the source of truth where the prefixes resides, and we have a job that regularly updates these prefixes from the source of truth and then updates the ACLs accordingly for them. Services, very similar to network, are also reusable entities. It is a set of port and protocol that you want to open access to and from. You can have a list of port or multiple ports that can be applied as source and destination services. I'd say a very simplified example of what a Capirca network or a Capirca service looks like. Right here on the left-hand side is a Capirca network. You have a name and a list of IP addresses. For simplicity, I've just mentioned one prefix, but you can have multiple prefixes mentioned. On the right-hand side is a service, which has, again, a name and a range of ports specified for it. Next is a term. Term is the Capirca equivalent of an access control element. A single term describes general connection for one or more flows using networks and services. A term should always have an action parameter, which helps us to decide whether or not this traffic is allowed, denied, policed, or just moved on to the next action. This is a Capirca term. We can add multiple match criteria to it, like source address, destination address, but for simplicity, I've just kept it like this. This vendor-neutral Capirca term gets converted into vendor-specific format with the use of ACL generator library. So on the left-hand side is the Juniper format, on the right-hand side is Arista format. So for a user who's not aware of any of these syntaxes, they just have to write a vendor-neutral file, and this is what we do for them to be converted to the rendered syntaxes. Next is project. Project is a collection of terms that are evaluated in the order that they're listed. We follow a top-to-down approach. So whichever term is listed first is matched with the incoming traffic first, and then it is evaluated in that order. This is what a project looks like. If you see, there is a list of terms, and each of which are evaluated one after the other. And then we finally end up generating a project, which looks like this. Finally, a policy. Policy is the culmination of everything that we've spoken about. That is what finally gets converted into the vendor-specific format and is pushed to the network devices. It is a collection of access elements that then comprise an access list. This is what a policy looks like. In the header, you specify which particular vendor you want to convert this to. I just have listed Arista for here, but then you can have multiple vendors specified and the filter type specified, and Capirca would take care of converting this into each of the different vendor-specific format that you want to do it for. Let's look at a brief Capirca config generation workflow. This is an overview of it. It is a lot of things go under the hood, but I'll just walk through it briefly. So the user adds that rule into Capirca config file. We have a policy.py file that loads the policy file. When I say policy file, it is the vendor neutral policy file into the Python classes that are created for every object. These platform library contains the individual platform modules. So we have a platform module for each of the vendors. So Arista has a module, and each of these modules then inherit the ACL generator library, which converts these policy objects into the syntax that at the end gets deployed to the devices. All right, this was a brief about Capirca. Now I will talk about what are the services that we've built around Capirca here at Meta. So just how I was explaining it, Capirca configs are very relational in nature, which means every network can be reused into multiple terms. Similarly, every term can be reused inside of multiple projects. And because of these relational nature, we've converted Capirca into an endco graph. An endco is an end framework provided by Golang, and all of this is again written inside. We've used Golang here to write all of our Capirca services. And we then, since we've converted this into a graph structure, we're able to query anything that we want out of these Capirca config files using a query language called endquery without having to manually go through each of these files in order to determine something. So this is a very simplified graph structure. At the top is the policy header, which then has an edge to a project header. For simplicity, I've just shown it as one-sided, but project also have an edge to policies. The projects have an edge to terms, terms have an edge to network services, and services have an edge to port ranges. Now, at any point of time, if a user, when I say user, again, I mean any team at Meta wants to say a query for their term, all they have to do is query the term edge, and they can then check using end query language that which network addresses and in turn domains is the term using. Yeah. All right, let's talk about risk assessment. This is again something that we've built around Capirca. Every change that is made to access list is can be some of these changes can break down an entire network. So at every point of time, we need to make sure that none of the changes that we're making affects the infrastructure in a way that the change is really bad. So we've developed something called as a risk assessment engine. What this does is that every change that, every commit that is submitted for requesting a change to our access list has to go through something called as risk assessment engine. The risk assessment engine breaks down the change that we've requested into different objects. I'll walk through this here. but we deep inspect the changes based on service network terms and policies. So every service that is added goes through a service checker. Every network that is added / deleted goes through a network checker, and so on and so forth. Every checker then gives us a risk score based on what sort of change that is made. It is a high-risk change, is it a low-risk change? And based on an aggregate of all the risks that we've calculated from each of the object, we give a final risk to the commit. Why was this needed is because we received, considering the huge network that we have, security team received on average about 30 network ACL change requests every day. And a lot of times, since it was a human approving those changes, we would miss some of these or end up stamping a change which would be bad at the end. And also, since the review process was manual, the change would take a lot of time, which would reduce, which would slow down the other teams. So for that purpose, we introduced these changes. What it does is, for changes that are low risk, we let the teams self-approve their changes. And for changes that are high risk, we provide the approver or whoever is reviewing the change a summary of all the changes that we're making. And that way, they have an idea of what sort of change is being done to our ACL policies. I'll go through an example here real quickly. So let's see, this is the sort of Capirca change that is being made. On the left is a term that is adding a destination service, which is SSH. SSH for us is a high-risk port or a high-risk service. We automatically tag this change as high risk. On the right-hand side, we're trying to add a network to a term. This network is a /8 network. For an IPv4 network, a /8 is a wide prefix, a very wide prefix indeed, which means we're opening up a lot of security holes in the process of allowing this change. So this change automatically gets tagged as a high-risk change by our automation checker. An aggregate of both of these changes then become high risk, and we then give a summary to whoever is reviewing it that, okay, this is a high-risk change, do you want to approve it or not? Next service that we've built around Capirca is a flow guardrail. There are some flows that are absolutely important for our company to function. If we bring down those flows, users cannot connect to our family of apps, or probably issues like this might happen, or our infrastructure might go down. So now to make sure that these flows are always open, every time a commit, a change request is published to us, we load the graph in order and check what all changes were made on a commit, and then we run something called as an ACL checker on these changes and determine if those critical flows are still open. If they are, well and good. If they're not, we flag that change and it is then not rendered by ACL gen and stopped right there. Memory profiling, we do this generally for Juniper QFXs. We identify the amount of memory which is used on Juniper QFXs per term, policy, and device type. And depending upon if this memory consumption has gone beyond 50%, this is done before rendering and pushing it to the device itself. If we identify this has gone beyond a threshold, we do not render the policy and we do not push it onto the device. This helps us in the way that we're not pushing bad changes onto the device and not bringing down the network that way. We have an auditing pipeline. This is run at a regular cadence, and it makes sure that there are certain audits that we have that we run our configs through and make sure that none of our policies fail these audits. If they do, this then prints an audit report and sends for an internal perusal. What are the wins from Capirca? We're able to deep inspect changes and document all our changes over time that we're making to ACLs. It reduces our time authoring and reviewing all of these ACL changes. The resolution time is faster. We have a safer development cycle. It is extremely easy for us to swap hardware inside of our network infrastructure because we do not have to care about doing a one-to-one conversion between different vendors. So to conclude, These are some of the pros from Capirca. We've had a streamlined network management, enhanced security, efficiency, because automated configuration helps us reduce manual efforts and minimizes errors. Vendor-agnostic configs help us to, we have more flexibility in terms of what hardware we want to choose, and the upgrade between different hardware is much more flexible when it comes to our ACLs. Future work, currently onboarding a new platform onto Capirca takes a good 2% month for us. We're trying to make this process more seamless. We have an in-house web UI support for visualizing Capirca configs, but the support is very limited. We're trying to work on that still. And we do not have a simulation technique to test the ACLs before they're deployed onto devices. So a lot of times we depend upon ACL are pushed into production and then we know what is broken. So we're trying to fix that as well. Thank you so much. I hope this helps. If you have any questions, let me know, and feel free to reach out with any feedback as well. Thanks.
Steve Ulrich, Next Top. A couple of questions. When constructing your rule sets in Capirca, do you find yourself able to construct rule sets that are well represented from the generator's perspective across all the vendors? Or do you find yourself having to find the minimum intersecting set of match and action criteria in order to achieve your objective?
Yeah. When you say rule set, you mean the risk assessment rule set, or are you talking about something else? I'm sorry.
No, good clarification. When you are not all the generators support all of the match criteria or the associated actions which may be supported across vendors.
Yeah.
Have you constrained your rule generation to a set of well-known and supported match and action criteria?
We've not done that. Every platform, for every platform, we have something called as accepted tokens and not accepted tokens. And so for the tokens that are specific to that, or the action and the rule sets which are specific to that particular vendor, we just add them to the accepted tokens. And the ones which are common to others but probably not accepted by this, we just add it to the non-accepted tokens, and then hence render our policy files. We currently try to support everything that a vendor-specific file would support, and not trying to keep it a centralized ACL gen library. So a lot of these changes are made in the platform library itself and not the main ACL generator library. So yeah.
And since there's nobody else, are there any plans to upstream the web UI for Capirca, or the rules analysis, or the risk analysis rather?
Currently, no, but the web UI support is very limited even for us. We've been working on it, but we've not been able to. But yes, once we have a full-fledged web UI support, yes, we plan on doing that at some point of time. But yeah. Any other questions? All right, thank you so much.